Double angle identities. Here are the 3 identities that you need to know. So let's go ahead and apply them. I'm going to use this first one to figure out what sine of 60 degrees is. Now, if I want to use this identity, I need to write sine of 60 degrees as sine of 2 times a. 2 times what will give me this 60? Good, so I can write this as sine of 2 times 30, right? Now I can use this formula. I can use sine of 2a. So notice it would be 2 sine of 30 degrees cosine of 30 degrees, right? Because my a value is 30. So if you think of the unit circle, here is 30 degrees right here, and the coordinate at 30 degrees is square root of 3 over 2 for cosine, and sine is 1/2 at 30 degrees. So that means this is 2 times 1/2 times square root of 3 over 2. Notice that 2 and 1/2 are reciprocals of each other. Those cancel out. I'm just left with square root of 3 over 2. And that's my answer. Sine of 60 degrees is square root of 3 over 2. You guys already know that based off of the unit circle, but here it is using the formula, the double angle identity. Now I'm going to use this second identity, cosine 2a, and let's apply it to another problem, cosine of 60 degrees. We can write this as cosine of 2 times 30 so that I can use the double angle identity. So the identity says if I have cosine of 2 times 30, I can write this as cosine of 30 squared minus sine of 30 squared. Let me just remind you of the identity. Cosine 2a is the same thing as cosine squared a minus sine squared a. So in this case, our a value is 30. So that's what I put here and here. So cosine of 30 degrees is square root of 3 over 2. And we're going to square it. Sine at 30 degrees is 1/2. And then we square it. I'll be left with 3/4 minus 1/4. This equals 2/4 or 1/2. So based off of the unit circle, you already know that cosine at 60 degrees, we already know that this is 1/2 and the sine is square root of 3 over 2. However, we found it using the double angle identity. Now let's figure out tangent of 60 degrees. I can write this as 2 times 30. So I'm going to use the double angle identity. The double angle identity says when I have something like this, I can write it as, let me show it to you. I can write it as this. So if I'm making my a 30 degrees, so that 2 times 30 is that 60. I'm writing 60 degrees as 2 times 30. So we're going to write 2 tangent of 30 divided by 1 minus tangent of 30 squared. Do you guys know what tangent is equal to at 30 degrees? Thank you, Luke. Square root of 3 over 3. So this is 2 square root of 3 over 3 over 1 minus square root of 3 over 3, and I have to square it. Now, once I squared it, the square root will cancel out with the squared, and 3 squared, this becomes a 9. So what I have in the denominator is 1 minus 3 over 9. That's what we have now. Now, if I want to combine these, the denominators need to be the same. So what I'm going to do is I'm going to change this 1 to a 9/9. So this denominator becomes 6/9, or 2/3, correct? This is 2/3. Okay, I'm going to come over here since I ran out of space. I have 2 square root of 3/3 divided by 2/3. Whenever you divide fractions, you flip the second one and you multiply. So this is 2 square root of 3/3 times, you're going to flip this. 3 is now in the numerator, 2 is in the denominator. The 3's cancel, the 2's cancel. Your answer is just square root of 3. Here's the next one. It's given that sine of an angle A is 4/5. And they're just telling you that angle A is an acute angle. It's in the first quadrant. So guys, before we even start, can you go ahead and draw a triangle of what this looks like? Okay, great. Ben, can you come up here and draw a triangle up here, please, for me? Use your finger. Once you guys have the triangle, you guys can tell me what cosine of A is and what tangent of A is. Oh. And then label it. They gave you sine of A. Perfect. Label A for me. Perfect. Thank you so much. All right, so that's what you should have drawn on your paper. If they told you what sine of that angle is, you should be able to find what cosine of that angle is. Ethan, what do you think cosine of A is? Good, I heard you. All right, so y'all should have used, Ethan, what'd you use to get through right here? Good, so what'd you do? 25 minus 16 gave you 9, and you took the square root of that? Very good. Okay, so that means cosine of that same angle is 3/5. Ethan, what's tangent of that same angle? SOHCAHTOA. Perfect. Thank you, Ethan. All right, so guys, sorry. Using the identity, go ahead and find these. Let me show you what I mean. On your identity sheet, you can see that sine of the double angle is going to be 2 sine A cosine A. You guys just told me that, well, this is given. Sine A, they told me was 4/5. So I'm going to put a 4/5 there. You guys just told me that cosine of A is 3/5. So I'm going to put a 3/5 right there for cosine A. Now you just multiply. 2 times 4 is 8, times 3 is 24, and your denominator, 5 times 5 is 25. So that's your answer. Now you guys use the double angle formula for cosine and tangent to find those values. All right, great. Ava, what'd you get for cosine of 2A? -7/20. Perfect. Okay, so did you guys use the double angle formula for tangent? Yes? Okay, let me know if you get the same thing that I get. You're using the formula. I'm just going to do sine of 2A over cosine of 2A since we already have those answers. So I'm going to do 24 over 25 divided by -7/25, which is 24 over 25, and you flip the second one. So 25 over -7, those cancel. Oh, got it right. Did you guys get 24 over 7? Sorry, -24 over 7. Y'all got that? Yes or no? I didn't get that.
I got 24 over 25.
Last question. Angle A is in the first quadrant. Where is the double angle? Where is the double angle? Quadrant 2? Yes, thank you. Sorry. Okay, because your sine is positive and your cosine is negative. Sine is positive and cosine is negative only in quadrant 2. So that means the angle 2A is in quadrant 2. Okay, I'm just going to do tangent 2A. If you solved for sine and cosine, you can just divide them and get this one. I'm going to use the formula. All right. Oh, why did I do that? Tangent of A is negative 2/3. There we go. All right, so that's our formula. We plugged it into the formula. So I get 2 times negative 2. This is negative 4/3. In the denominator, I get 1 minus 4 over 9 because I squared both of those. I'm going to turn this 1 into 9 over 9 so that the denominators are the same. So this is 5/9. Now you just flip the second one and multiply. So I get negative 4/3 times 9 over 5. This can simplify. So I get negative 12 over 5. Is that what you guys got? Perfect. Okay, next one. We're going to express sine 4x in terms of the angle x. So guys, instead of my angle being a 4x, I just want a simple x. That's what it's saying. Express it in terms of x, not 4x. Okay, so I'm going to give you some hints down here. Remember, when I have sine of 2x, you can use the double angle identity. This is 2 sine x cosine x, right? If I have cosine of 2x, y'all remember the formula? Squared. Exactly. Those are my two identities. I'm going to use that. Okay, so I can use my identity here. I'm going to try to make it look like this. So I'm going to write this as sine times 2. What else do I need? 2x. 2 times 2x is still 4x. So that's how I'm going to write it. And notice, guys, it's in that format. 2 times something. 2 times something. So I'm going to use this formula. This will be written as 2, and then I have sine of 2x, cosine of 2x. Do you guys see how I use the identity? Okay. So notice in my formula here, this x value, it goes to sine x and cosine x. So this value, in the same way, it went to sine and cosine. Okay. All right, let's continue. Because guys, I want to express all of this in terms of my angle just being x. Right now, my angle is 2x. I don't want 2x and I don't want 4x. I just want a plain old x. So let's continue using the identities. Okay, so guys, notice right here, I have sine 2x. Do you guys see that? I can use this. Sine of 2x is 2 sine cosine. So I'm going to write this as 2 sine cosine. That blue. And look, cosine 2x, that's right here. So I'm going to put that in as well. And let's not forget that 2 in the very front. So I'm just using my identities. 2 times 2 is just 4. So I get 4 sine x cosine x times cosine squared x minus sine squared x. All right, guys. So now I expressed my answer in terms of x. Notice these all just have a single x as the angle. No longer 2x, no longer 4x. Now, if I wanted to simplify this, meaning I don't have parentheses, I can distribute. So I can put all of this here and here. So this would be 4 sine x cosine, and cosine squared, that's cosine cubed, minus, I'm going to do all of this times the sine. So I'm going to have 4 sine x times sine squared is sine cubed, and I have the cosine. So that's my answer if I distribute it. All right, next problem. We're going to verify this. So just like we did in the last unit, I'm going to change one side of the equation and keep the other side the same. So I'm going to use my identity right here. I want to change this. What identity? What can I replace that with? Exactly. That's my identity. Do you guys see what cancels out? Yep, sine cancels with sine. So now I am left with 1 over 2 cosine x. And actually, this can be written as 1/2 times 1 over cosine x. Do you guys know what 1 over cosine x is equal to? Secant. So this is 1/2, and 1 over cosine, that's just secant. Now, both sides equal each other. That is how you verify this identity. Make sure, like I did, you show every step. Don't skip steps. I need to see your pathway on how you get to the very end. All right, so you guys try the next one. Okay, so verifying this one. Since this is a squared, you're going to write it 2 times. Sine x minus cosine times sine minus cosine. And we're just going to FOIL. Sine times sine is sine squared. Sine times cosine is sine cosine. Negative cosine sine is the exact same thing. And then negative cosine times a negative cosine is now positive cosine squared x. This is just -2 sine cosine, because you have 2 of them. And they're both negative, so -2. Sine squared and cosine squared is just 1. This is the identity, sine 2x. And that matches.